All right, let's get ready for our Unit 9 test. And our test is basically covering trig and vectors. So when I look at these problems, for number 1, I want to find the value of x for each. And the first question I want you to ask yourself is, when I'm looking at this triangle, is it a right triangle? If it's a right triangle, then we're allowed to use two pretty easy tools that we learned. So for right triangles, we're allowed to use the Pythagorean theorem if we know two sides and want to find the third side. And we're also allowed to use SOHCAHTOA, our way of remembering the three trig functions that we learned about: sine, cosine, and tangent. So if we look at the first problem, it is a right triangle, so I can use one of these two tools. And I'm looking for a side, but I don't know the other side. I only know one. So we're going to go ahead and use SOHCAHTOA. When I set up SOHCAHTOA, I've always set up this little no chart, and I start with my angle, and my angle is 32 degrees. And the two sides that I have are x and 41, and I want to identify them in comparison to this angle. So if I'm sitting at this angle, opposite me is x, and since this is the hypotenuse right here, that leaves 41 as my adjacent side. So I now go in ahead and I look at my SOHCAHTOA, and I have O and A, opposite and adjacent, and the rule that I'm going to need, the only one that has the O and the A, is tan. So I set everything up. The tangent of my angle, which is 32, equals opposite, x, over adjacent, 41. So I have everything set up here. Okay, we need to go ahead and solve this problem. So I'm going to use that in a different color. I want to get x by itself. So the thing I need to get rid of first of all is 41. I'm going to cross those out. If I multiply this side by 41, I multiply the other side by 41 as well. Keep the balance. And that tells me that x equals 41 tan of 32 degrees. I'm going to type that all into my calculator in one go. I don't want you to use any decimals until the end. So in my calculator, I'm literally typing 41 times tan 32, close your parentheses. Enter. And that tells me that x is 25.619. Please just give me 3 decimals and then stop writing. Perfect. That would be the value of x here. All right, next problem. I'm looking at the triangle. I know that it's a right triangle right away. I have two sides, which means if I needed the third side, I'm allowed the Pythagorean theorem, but that's not what I'm looking for. Here I'm looking for the value of x right here. And in order to do that, I'm going to need to use my SOHCAHTOA again. So I'm going to do my little no chart. My angle this time is actually x. That's a little bit different, but we're still doing the other two in relation. I have a 10 and I have a 13. X, next to x is 10, so that's adjacent. And 13 is across from that 90-degree angle, which makes it the hypotenuse. So now I look up at SOHCAHTOA and I say, all right, I have A and H, Ka, that goes with the C, which means now we're looking at the cosine. So the cosine of my angle, x, equals adjacent 10 over hypotenuse 13. Now once again, I'm going to switch colors so that you can see what I'm doing, but I'm solving for x. Now this is a little bit different. X is stuck with this thing called a cosine, and I'm not allowed to divide by cos because it's nothing by itself, it's an operation. And in order to get rid of operations in math, we have to do the opposite of that operation, and that's actually called the inverse. And we would denote it with cos and then the -1. Cosine -1 will get rid of the cosine, and I'll leave with you with an x. If I've done it to this side, I have to do it to this side as well. So we find out that cosine equals cosine -1 of 10 over 13. All right, that's something I can type into my calculator. I do it by hitting second cosine. It gives me that cosine -1, 10 divided by 13. That tells me that x equals 39.715, and because it's an angle, that would be degrees. So far, so good. Last but not least, we are moving on to the last triangle. And once again, I'm looking at the triangle. It's a right triangle. I'm looking for a side, but I only know one, so the Pythagorean theorem is out. I'm going to do my last no chart. The angle that I always start with is 65 in this case. Opposite that angle, so we have an x, which is opposite it, and the 16 is adjacent to it. And what uses opposite and adjacent is the tangent. So let's go ahead and set that one up. The tangent of my angle 65 equals opposite, that's x, over adjacent, that's 16. Okay, just like that first problem, we're going to solve this by going ahead and multiplying by that number on the bottom that we want to get rid of. And in my calculator, this leaves me with x over here, 16 tan 65. I'm going to type that right in, 16 times tan 65. And that gives me back 34.312 equals x. All right, next problems. Okay. Numbers 2, 3, and 4 are all word problems involving trigonometry. So, and if you'll notice, every single one of them has a special keyword that we have talked about in class. We talked about specifically angles of depression, angles of elevation, and those are in both of these word problems. You'll find that in all of the trig word problems. Okay, so let's talk about it. Number 2. We need to draw a little picture. A monument stands on level ground, and I don't care what the monument looks like. I'm just going to draw kind of a straight building. Stands on level ground, so here's the ground. The angle of elevation to the top of the monument taken at a point 320 feet from the foot of the monument is 27 degrees. It's a little wordy, but basically what they're saying is there's a point that's 325 feet from the bottom. So let me put the point here, 325 feet from the bottom. And there's an angle of elevation, elevation meaning to go up, to look up, to elevate. Angle of elevation is 27 degrees. So for every angle of elevation depression problem, we start with a horizontal line, which I have here, and I have to look up 27 degrees, which makes this angle 27 degrees. We want to know how high is the monument to the nearest foot. That would be over here, the height of the monument. So let's go ahead and see what we know. We've got a right triangle because height is always measured with a right angle. And we need to know a side, but we only know one, which eliminates the Pythagorean theorem. So we're back to SOHCAHTOA. What do we know? Well, our angle that we have is 27 degrees. We have x and 325. X is opposite. 325 is adjacent. It's not the hypotenuse. This would be the hypotenuse over here. Opposite and adjacent, that's tan again. And so let's solve it. The tangent of 27 degrees equals opposite, that's x, over 325, that's adjacent. If we multiply through by that 325 again, you find that x equals 325 times the tangent of 27, just like the other two examples. I'm typing that in, 325 tan 27, and I get 165.595. And this is in feet because this is a real world problem, so we can actually give real world measurements to it. All right. Next problem. I'll change the color. So, from the top of a 108-foot high building. Okay, so I'm going to start with a building. The only thing I know about this building is that it's 108 feet high. An observer measures the angle of depression to a bike on the sidewalk as 29 degrees. So basically what they're telling me is there's someone up here and they're looking down at a bike. Here's the bike. And they're looking down at an angle of 29 degrees. So we have to remember angles of elevation and depression start with a horizontal line. If that observer who's sitting right up here was just looking straight out, that would be their horizontal line, but instead they're looking down 29 degrees towards that bike. The angle of depression is from the horizontal down. We want to know the distance to the nearest foot, the bike to the base of the building. Okay, so here's the bike, here's the building. We want to know this side. Now, you might say that we look like we have a right triangle because height, once again, is measured with a right angle. And we have a 29-degree angle, but we don't have it inside our triangle. However, you should remember that angle of elevation and depression are congruent. So if this observer has to look down 29 degrees, this bike has to look up 29 degrees. So I know that this angle is also 29 degrees. Do not mistake that with this angle in here. This angle in here is not 29 degrees. It's 90 minus 29 degrees. Okay, now that we've established that this is the 29 degree angle, I'm going to write my no chart. My angle is 29 degrees. I have x and 108. X is adjacent to that 29 degrees, and 108 is opposite. So opposite and adjacent, still tan. We're going to write out our equation. The tangent of 29 is equal to opposite, 108, over adjacent, that's x. Now we talked about little tricky ways to solve for x, and you should remember that in a proportion, which is really what we have here, we're allowed to trade these two numbers. We're allowed to literally switch their positions. So this becomes x equals 108 divided by the tangent of 29. I'm going to type all that into my calculator. 108 divided by tan of 29, close my parentheses, and I get 194.837. That is how far away the bike is. All right, last one that I'm going to do in this video is number 4. A hang glider takes off from a 300-foot cliff at an angle of depression of 17 degrees. How far did the glider fly? How much ground distance did he cover before he landed? So here I'm asking two different questions. All right, let me give myself a little bit more space. We've got a hang glider. Here we've got a cliff right here. The cliff is 300 feet. The hang glider takes off at an angle of depression. So here the hang glider is up here. From the horizontal down is 17 degrees. Angles of depression are from horizontals down. And they want to know two things. How far did they fly in the air? So I'm going to call that x. And what ground distance did he cover? I'm going to call that y. So ground distance would be y. How far in the air? That would be x. Okay, so two different problems here. Just like we did before, we're going to take that 17, which is the angle of depression. We're also going to make it the angle of elevation, because those two are congruent. And so now I've got my right triangle. This is a right triangle because the height of the cliff is perpendicular to the ground. And I can solve for either one first of all. In fact, first I'm going to solve for x. So for my first chart I know that the angle is 17. In fact, I'm going to write it all in one chart. The angle is 17. We have 300, which is opposite that 17. X is the hypotenuse, and y is adjacent. So when I'm solving for x, I can kind of block out right here, block this out. Just looking at the top information, opposite and hypotenuse, that is sine. So the sine of my angle, 17, equals opposite over hypotenuse, which is x. Okay, we just talked about how to solve this. X is on the bottom. I want to bring it up. The quickest way to do that is to take this term and trade them. They're called extremes in a proportion. So x equals 300 divided by sine of 17. Type that into your calculator just like you see it. 300 divided by sine 17. And that tells me that x is 1,026.091 feet, because this is the cliff was measured in feet to begin with. That's how far he flew in the air. Okay, now let's talk about how far his ground distance is. We're trying to solve for y. So now I can kind of almost ignore this for a second. I have an angle opposite and adjacent. Our old friend tan. So tan of angle, the angle 17, equals opposite, 300, over adjacent, that's y. We're going to do the same thing we just did. We're going to switch these two terms. Switch these two terms right here. We end up with y, which is 300 divided by tan of 17. And when I do that, I get 300 divided by tan of 17 using my calculator, which is 981.255 feet. So he traveled 126.091 feet in the air, 981.255 feet on the ground.